Hello, everybody. Welcome to the very last video for 10C Online. We are reviewing our final unit, and then from here on out, it's just going to be some assignments to wrap things up. So this is our last lesson video, which is just a review. So to kind of just look ahead, right, we're reviewing today. Wednesday is going to be the weekly assignment for this unit. And then Thursday, I'm giving a replacement assignment. So that'll kind of cover everything we've done so far online. And that'll replace one of your weekly assignments. So I'll post that on Thursday. And then on Thursday and Friday, all you're doing is catching up on everything you've missed. So if you're all caught up already, great. Finish this weekly assignment on Wednesday, you're done. If you're missing some things, Thursday and Friday, that's your opportunity to get everything taken care of. And then we're hitting the road and we're all done and we're ready for summer. So again, today's review. Wednesday is the weekly assignment, and that's our systems of equations assignment. And then Thursday, Friday is where you have the replacement assignment, and you can also go and take care of anything you're missing. Okay, let's jump into the review. Okay, we're jumping into the review package. So similar to the last few units where not in the workbook, but I'll post the PDF and you can copy down the questions or just write down your work or whatever. And I'll post the key as well. So I'm going to go through, do maybe about half of the questions, and I'll leave the other half for you to finish for some studying. And then you'll be all ready to roll for the assignment tomorrow. So solving systems equations. Not a lot to this unit. Okay, I would say there's really three things we want to look at. Number one would be solving. How do I solve a system? And we have a few methods to do that. Number two is, can I know how many solutions a system has? Maybe it has one solution. Maybe it has an infinite amount. Maybe it has no solutions. And then the third thing is what we just looked at, which is the word problems. Can I set this up with a context? So first question says, state the solution. Well, if I'm solving a system, I am saying, tell me the point, tell me the x and y that is on both equations or on both lines. In other words, tell me the point of intersection. Okay, so if I have a graph in front of me, the point, the x and y that satisfy this system would be, we call it the point of intersection, POI. X is 4, y is 2. There you go, that's my answer. So solving graphically is my easiest way. I asked you to solve. You look at the graph, you find the point of intersection. Okay. Question number 2 asks a similar thing. It says graph and state the solution to y equals 2 minus x. That shouldn't say or, that should say and y minus x equals negative 4. Okay, well, what I'm going to do is I'm actually going to use my calculator to help me out. So y equals 2 minus x. That's what I'm going to type into y1 on my calculator. And then the other one, y minus x equals negative 4. Well, I'm going to rearrange that so that I have y equals. Okay, so I get y equals x minus 4. Okay, and that's going to be y2. So any equation I give you, if you rearrange them both to y equals, you can go over to your calculator and type them into graph. 2 minus x. The other one is x minus 4. X minus 4. Okay, and I'm going to go zoom standard. There's the first one, there's the second one. So could I have graphed it over here? Yeah, I'm not going to bother. Here's a really useful skill is if I can graph them in my calculator, okay, I can just find the point of intersection, which I go second, and then calc, which is above trace. Second calc, find the intersect, which is 5. Am I on the first curve? Yep, I'm on the blue one, enter. Am I on the second curve? Yep, I'm on the red one, enter. And then it asks me to make a guess. So I move my cursor pretty close and hit enter. And it tells me x is 3, y is negative 1. There you go. Okay, so if your equations are already in y equals, type it into your calculator, boom, we're done, right? If it's easy to range to y equals, rearrange to y equals, boom, you're done. So graphing is the first method of how to solve, okay? And then we also know the algebraic ones. We'll get to that later. All right, how many solutions are there? So this is a kind of the second type of thing we look at. What I'm going to do is we're actually going to look at it. There's three options. You could have one solution. You could have zero solutions. We'll do that one next. Okay. Or you can have an unlimited amount. So infinite or an infinity solutions or an infinite amount of solutions. Okay. Well, the situations where that happens, I'll start with infinite solutions. That's when I have the same line. It's one line and then that same line right over top of it. So that happens when I have the same slope, okay, and same y-intercept. Okay, that's when I get that happening. My slope is exactly the same and my y-intercept is the same. Okay, zero solutions was when, okay, these lines are like side by side. They're like train tracks. They're never actually going to meet. Okay, they're parallel lines. Well, I know parallel lines have the same slope, but this is where I would have different y-intercepts. Okay, they're close, but the y-intercept is different, so they're parallel lines. One solution, this is when my lines cross. Okay, and it can happen anywhere. The only thing you need to have one solution is a different slope. Okay, that's the only thing. So as soon as I have different slope, I know it's one solution. If my slopes are the same, then it has to be zero or infinite solutions. Okay, so we go to something like this. It says, how many solutions are there in each system? Okay, 2y plus 8 equals 4x, and then y equals 2x minus 10. Well, what I'm going to do is I'm actually going to rearrange the 2y plus 8 equals 4x. And I'm going to start by moving the 8 over. So 2y equals 4x minus 8. Divide by 2. Y equals 2x minus 4. Okay, so there's not a lot of room here to show my work, but that's okay. So here's one equation, here's the other. What I notice is they have the same slope. 2x and 2x, that's the same slope, but they have a different y-intercept, so that means zero solutions. Okay, zero solutions. B, let's take a look at B. 2x minus 12 equals 4y. And then I've got 1/2 x minus 3 equals y. So that one, maybe I write it this way. Y equals 1/2 x minus 3 is already rearranged. The other one, I got to do a little bit of work. I have to divide by 4. Okay, so I would get, I'm just going to show this down here. 2 divided by 4 is 1/2 x minus 12 divided by 4 is 3 is equal to y. Oh, hey, that's the exact same equation. Has the same slope, has the same y-intercept. That's where I'm going to have an infinite amount of solutions. Okay, so taking a look at the last one, if I was a gambling man, I would look and say, it probably has one solution because I've already had one zero, I've already had one infinite, but we should never, take things for granted. So I'll actually check. Okay, so the first one, I move the 3x over, y equals negative 3x plus 2. The other one, what would I do? I might move the y first. 1/4 x equals y minus 5. 1/4 x plus 5 equals y. And then maybe I just switch the y around. Y equals 1/4 x plus 5. So I've rearranged both equations, and the first thing I notice is they have a different slope. So as soon as they have a different slope, I know there's going to be one solution. It's going to cross one time. Okay, so with these questions, I'm not actually asking you to solve. I'm asking you to say, what would the solution give me? Would it give me 1, 0, an infinite, whatever? Okay. 4 is a similar question. You can do that one on your own. 5. For which system is 4, 0 a solution? So this is something where we haven't really actually done something like this, but we have the skills to do it. Okay, so I have 4 systems, A, B, C, and D. One option here is solve system A. See if you get an answer of 4, 0. Solve system B. See if you get an answer of 4, 0. And so on and so on. That's a lot of work. That involves me solving 4 different systems just to see if I get the answer. What I'm going to do instead is I know how to verify a solution. I know how to check a solution. So if I have this point, if it is a solution, that means plug the x and y into both equations, and it needs to satisfy both equations. If it doesn't, okay, then I know it's not the right answer. So verify it for A, verify it for B, verify it for C, and D, so on and so on. Okay, so let's do that. Okay, we're going to verify for A. X plus 6y equals 23. So 4 plus 6 times 0 equals 23. Well, 6 times 0 is 0. So 4, I don't have to write. I'll stop writing that. I don't have to write that 23 down the whole way. Okay. I get a simplified of 4 on the left. And you say, well, on the right, you had 23. So 4 does not equal, so an equal sign with a line through it, 23. Cross that off. That cannot be a solution. I don't even have to bother checking the second equation because it didn't work for one of them. It needs to work for both equations in order for it to be a solution. Okay, let's try B. All right. 6x plus y is supposed to equal 22. So 6 times 4 plus 0 is supposed to equal 22. And I'm just going to draw my line down. Okay, well, 24 plus 0 is supposed to equal 22. I get 24 on the left. I get 22 on the right. Left side does not equal right side. Cross that option off. So I'm not doing that much work, and I'm going to be able to find my answer. All right. 2x plus 6y is supposed to equal 4. 2 times 4 plus 6 times 0 is supposed to equal 4. No. 8 plus 0 is 8. Left side does not equal right side. So I know my answer. I know it's D. But just for the sake of this, let's actually prove it. Okay. X plus 6y is supposed to equal 4. Well, my x is 4. My y is 0. Oh, yeah, I can see this one working. 4 plus 0? Yeah. Left side equals right side. I simplified down to a 4. And on the other side, I was simplified down to a 4. Okay, so one of the equations works. But I also have to check it for the second equation. It's not good enough just to satisfy one. I have to satisfy both. Okay. 2 times 4 plus 4 times 0 equals 8. 2 times 4 is 8. 4 times 0 is 0. Oh, yeah. Left side equals right side. There you go. D is my answer. So that's verifying, which you can always verify your questions. You don't have to, but verifying can be useful when I'm actually solving something. Okay. What is the solution to the system x minus 2y equals negative 2 and 3x minus 2y equals 2? I'm going to do this one algebraically. So you could absolutely rearrange these both to y equals, put them in your calculator. I'm going to say, let's do this algebraically. And what I'm going to look at is I have the choice between substitution and elimination. I am going to do substitution. Okay. Well, that is substitute. Oh, that is horribly spelled wrong. All right, let's try that again. Substitution. Okay. What I'm going to look at is I have equation 1 and I have equation 2. And with substitution, I need to pick either of my equations. It doesn't matter which one. And then I'm going to rearrange it for x equals or y equals. And the reason I chose substitution is because it's really easy to get this equation to x equals, right? I'm going to start with equation 1. X minus 2y equals negative 2. Well, add 2y to both sides. And I have x is equal to 2y minus 2. Okay? And then what this allows me to do, I rearranged equation 1. I'm going to substitute it into equation 2. So equation 2 being 3x minus 2y equals 2. Instead of saying x, oops, that's supposed to be an x. Instead of saying x, I'm going to say 2y minus 2. I'm substituting this in. This replaces your x. 3 times 2y minus 2 minus 2y equals 2. And now I have an equation I can solve. There's only y's left. 6y minus 6 minus 2y equals 2. Or 4y minus 6 equals 2. Move my work up here to solve. 4y equals 8. I would add 6 to both sides and divide by 4. 8 divided by 4 is 2. Okay? Put a box around that. You have your answer. Y is equal to 2. Now, I know part of solving is I need my x and I need my y. So I need to take that and I need to find x. Well, luckily, I have this nice, beautiful equation. X is just 2y minus 2. Okay. X is 2y minus 2. Plug in that value now. X equals 4 minus 2. Or, x equals 2 as well. Okay. So that's solving by substitution. So with solving, there's 3 ways we can solve. The first is graphically. Second is substitution. Hey, I got my answer. I could verify it if I wanted, but I don't have to. And the third is elimination that we're going to do down below here. Okay, so we're looking at question 7. Phil has been asked to solve the system of equations given by this. Okay, the following is his solution. Is it incorrect? Explain and correct the error. So what I'm going to say is, okay, Phil, good for you. You did your work. You made a mistake. Okay, let's just do this one and we'll see where he went wrong. So we're going to use elimination. We've already looked at substitution and graphing. We're going to do elimination. Okay, elimination, what I look at is with my equations, I stack them up. X's go on top of each other, Y's go on top of each other, and constants go on top of each other, just like this. And what I'm going to say is I want to somehow get the same coefficient on my x's or my y's so that I can add the equations together and get rid of them. Okay, and you'll notice what Phil did is Phil got it to 7x, and then subtracted the equations. That's totally something we can do. I always just prefer to add them. So what I'm looking at is the x and 7x. I could easily turn this x into a negative 7x if I multiplied by negative 7, okay? Which I am allowed to do as long as I multiply all 3 pieces, this side and this side. I get negative 7x plus 21y equals 29 times 7, 203, okay? The bottom equation, 7x minus 8y equals negative 99, didn't change anything. And then what I'm doing is adding them together, okay? Negative 7x and 7x, boom, gone. That's why I made it a negative 7, so that I could add together and cancel. 21 minus 8y is 13y. And then I have 203, subtract the 99, you get 104, okay? So already you see the difference. And what they forgot to do, I'll just point it out now, they didn't multiply this negative 29, right? They made everything 7 times bigger, but they forgot about the constant on the other side. Then you need to multiply all 3 pieces. Okay, from here I can solve very quickly. My divide by 13, divide by 13. Y equals 104 divided by 13, 8. Okay, y is equal to 8. And that's one of the best parts about elimination is my first variable is a really quick solve. Okay, my first variable is a very quick solve. what I need to do from here is I need to recognize, okay, well, I need the x and I need the y. So I need to use the given equations. I go back to these given equations and I say, can I plug the y in and easily solve for x? So it doesn't matter which one I pick. I'm going to sub back into the first one because it's smaller. It's got smaller things. So this has to be true. X minus 3y has to equal negative 29. So 3 times 8. And I can solve from here. X minus 24 equals negative 29. And now it's just a one-step solve. Add 24 to both sides. You get an answer. X equals negative 5. X equals negative 5. Done. Okay, so I got the right answers. Okay, we know the mistake that Phil made, and then I solved this one correctly with elimination. All right, so there you go. That's all 3 methods that we've now looked at. Graphically, substitution, and elimination. All right, a couple of questions left. These are word problems. I'm not actually going to solve these ones. I'm just going to set them up. Okay, the first one, all it asks us to do is set it up, so we'll do that. And then 9, I'll set it up, and then that's where I'll end the video, and you could solve it as part of your studying. Okay. So with word problems, we try to build our context. So it says a rectangular field is 5 feet longer than it is wide. The total length of the fence used to enclose the field is 750 feet. What would the system of equations be? I'm going to draw a rectangle, and then I'm going to make my let statement. And it's very obvious. Let W be the length, or sorry, L be the length, W be the width. Okay. And so like I have length and W and W. Okay, all around. The first piece of information, okay, is a rectangular field is 5 feet longer than it is wide. So my length is 5 more than the width. I'm 5 longer. Okay, so that's actually one of my equations. I can say the length is the width plus 5. Whatever the width is, my length needs to be 5 longer than that. Okay. The second equation, the total length of the fence used to enclose the field is 750 feet. Or in other words, perimeter equals 750. Okay. So perimeter is the length plus the width plus the length plus the width. Or my 2 lengths and my 2 widths. Okay. 2 lengths plus 2 widths has to equal 750. And there you go. Those are my 2 equations. Okay. One was set up based on the kind of reference between length and width, and the other is that piece of information they gave me, the perimeter or the length of the field. Okay. So that would actually be a great multiple choice question, right? Here's a system. Tell me the equations you would use to solve it. Okay, tell me the system. But we're not actually going to solve it. Okay, 9. Another word problem. John operates a snow removal business. He charges $20 for a sidewalk and $50 for a driveway and sidewalk. Okay, one weekend, John made $800 by doing 25 jobs. If S represents the number of sidewalks and D represents the number of driveways, how many of each did he complete? Okay, so I don't need this let statement, but I'm going to write it out just to be clear. S, so let S be number of sidewalks, and D is the number of driveways. Okay. Well, I need 2 equations. If I'm going to solve this thing, I need 2 equations. There's all about the money, $20 for a sidewalk, $50 for a driveway. Okay. He made $800 doing 25 jobs. So what I see is that 25, if I have a fixed amount, the amount of sidewalks plus the amount of driveways has to equal 25, right? That's the only option. Maybe he did 20 sidewalks and 5 driveways. Maybe he did 15 sidewalks, 10 driveways. But no matter what, between S and D, they have to add up to 25. So that's my first equation. My second one comes from the money, which says at the end of the day, or end of the week, I guess, or month or whatever it was, weekend, okay, He made $800. Okay. And talking about money, $20 for every sidewalk, $50 for every driveway. So 20S plus 50D, that's the amount of money he made from each. If I add those together, it better equal 800. And there you go. Okay, I've got my two equations now. I'll just go dot, 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 and you can continue onward and finish that one as part of your studying. So there you have it. Systems of equations review. So we looked at solving graphically. We did one with substitution, one with elimination. We just looked at some word problems. And we also looked at, hey, how do I know how many solutions I'll have? Okay, so that's the whole unit. So you've got maybe 3 pages left. Okay, a little bit of review to do today. There you have it. Final video is completed. We are done with the lesson videos. So you're ready to roll on with some review, get that weekly assignment done. Maybe you do the replacement assignment if you want to replace one of your lower assignment marks. And yeah, other than that, smash the like button one more time, hit subscribe even though there's no more videos. Thanks for watching all the videos throughout this online semester. And hopefully I see some of you guys in the hallways in the fall.